We're going to start with these two trig ratios that we're very familiar with, sine of theta and cosine of theta. Now we know that sine of theta is equal to y over r, and cosine of theta is equal to x over r. What we're going to do is we're actually going to solve sine of theta for y in terms of r, and we're going to solve cosine of theta for x in terms of r. This is a very simple process. To clear a denominator, you simply multiply both sides of the equation by the denominator. This cancels, and you get that y is equal to r times the sine of theta. In the same manner, we're going to multiply both sides of this equation by r, and we'll get that x is equal to r times the cosine of theta. The way we'll use that information is we'll start off by drawing an angle in standard position on the coordinate plane. There's your initial side, here's your terminal side, the angle is theta, and here is any point P on the terminal side. The distance from the origin to point P is the value r. And we know that this is our x distance and our y distance, which gives point P coordinates x, y. But as we proved on the previous slide, point P is actually r times the cosine of theta, r times the sine of theta. We'll use this fact to prove what we call the law of cosines. To prove the law of cosines, we'll draw a triangle on the coordinate plane. It doesn't matter really if you draw an acute or an obtuse triangle, but the angle here is theta. There's theta. And we're going to align angle C, which is theta, on the origin. Angle B will have coordinates A, 0. The reason is because this distance is opposite angle A, so it'll have a length of A. What that means, the side opposite C will have a length of C, and the side opposite B will have a length of B. The coordinates at angle C are 0, 0. The coordinates at angle A are B cosine of C, B sine of C. The reason that these are the coordinates, angle theta is now angle C. So instead of theta, we're putting C. This distance B is our R, our radius. So that's why that's showing up here. Now what we're going to do is we're going to apply the distance formula to side C, which would be line segment AB. So that gives us C squared is equal to, now here, remember we're looking for distance between A and B, so it'll be x1 minus x2. Well, x1 would be B times the cosine of C minus A squared plus, now we need y1 minus y2, which is B sine of C squared. We could write minus 0 if we need to, but that isn't necessary. we have to expand this. Remember foiling? So when we FOIL, we get that c squared is equal to b squared cosine squared of c minus 2ab cosine of c plus a squared. So all I've done at this point is squared this part of it. Now I have to square the other part. For that I get plus b squared sine squared of c. Now I'm going to rearrange like terms. Where are my like terms? Well, I kind of have a b squared here and here, so I can start putting those components together, and what'll happen is I get c squared is equal to, I'll put my a squared first, then I'm going to put everything together that has a b squared in it, so I have b squared cosine squared of c plus b squared sine squared of c. Then I'll finally put the minus 2ab cosine of c. What I'll do next is I will factor this b squared out. And that gives me c squared is equal to a squared plus b squared times cosine squared of c plus sine squared of c minus 2ab times the cosine of c. Now you have to remember back to your Pythagorean identities. We have an identity that says sine squared of an angle plus cosine squared of the same angle are equal to 1. So we can replace this entire section with the value 1. And 1 times b squared is simply b squared. When we finish, we get c squared is equal to a squared plus b squared minus 2ab times the cosine of c. This is one form of the law of cosines. The other two forms of the law of cosines are set equal to b squared and to a squared. Some hints when you're trying to remember this. If c squared is on the left-hand side, then angle C is on the right-hand side, and sides A and B. So if you have side C on the left, you do not have side C anywhere on the right, but you have angle C. The same rule will apply for the b squared and a squared versions. So now let's try an example. We have triangle ABC, and we're given that side B is 10, side C is 14, and that symbol is angle A is equal to 54 degrees. Determine the value of side A. So we will use the a squared version of the law of cosines. And we get a squared is equal to b squared plus c squared minus 2bc cosine of angle A. So that would be 10 squared plus 14 squared minus 2 times 10 times 14 times the cosine of 54 degrees. This entire thing can go into your calculator. Just make sure that you're using parentheses appropriately. You'll get that a squared is equal to 131.420. Then remember you have to take the square root of both sides because we're looking for a. And you'll get that a is 11.464. Here's another example. Again, we're looking for side A. So A squared is equal to 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 38. We'll get that A squared is 54.877. When we take the square root of both sides, we'll find that A is 7.408. This problem is actually a little bit interesting because you don't know if you're looking for angle A, angle B, or angle C. What you know is that you're looking for the largest angle and the smallest angle. So here are some clues. The largest angle is always opposite the largest side. So that tells us that we're looking for angle B. The smallest angle is opposite the smallest side, which means that we're looking for angle C. So we'll first start off by looking at angle B. We don't really have a method to solve for angle B, so we have to do a lot of algebraic manipulation to make that happen. So we'll start with the law of cosines. The one that we know will have angle B in it starts with b squared. So it's b squared is equal to a squared plus c squared minus 2ac cosine of b. So that becomes 29 squared is equal to 18 squared plus 16 squared minus 2 times 18 times 16 times the cosine of b. So now it's just a matter of doing algebra. I will have to subtract 18 squared from both sides. I will have to subtract 16 squared from both sides. When I do that, I get 261 is equal to negative 2 times 18 times 16, which is negative 576 times the cosine of b. So now I have to divide both sides by negative 576. That gives me a negative 0.453 is equal to the cosine of b. Now it's a matter of untrigging, so to get b, I will take the inverse cosine of negative 0.453. This tells me that angle B is 116.944 degrees. To find the smallest angle, I will repeat this process, but this time I need law of cosines that has angle C in it. So it will be c squared is equal to a squared plus b squared minus 2ab cosine of c. So that gives us 16 squared is equal to 18 squared plus 29 squared minus 2 times 18 times 29 times the cosine of c. Sorry, I ran out of room there. So the same process, I'm going to subtract 18 squared and 29 squared from both sides. When I do that, it gives me negative 909 is equal to negative 1044 cosine of c. And to get that 1044, I multiplied negative 2 times 18 times 29. So now I will divide both sides by negative 1044. That gives me 0.871 is equal to the cosine of c. Now I have to untrig this, so angle C will be equal to the inverse cosine of 0.871. and that gives us an angle C of 29.461 degrees. Now we can check to make sure that this is in fact the largest and that is in fact the smallest, and the way we'll do that is we will find the angle that will make them equal to 180 degrees. So if I take 180 minus 116.944 minus 29.461, I should get an angle that's in between those two. And I get that angle A, which would be the middle angle, is 33.595, and that value is in between the other two. Our final problem is a word problem, and like every word problem that we're going to do, you will need to draw some kind of sketch to see exactly what the question is answering. So we're told that Middleton is 8 kilometers east of Mandra. Okay, I can draw that. Here is one city, here is the other city. They're 8 miles apart. So Middleton is the one on the east. Okay, so I can write that, and then Mandra is over here. Now Deerfield is northwest of Mandra. Well, here's Mandra. There's north, there's west. So Deerfield is somewhere over here. And amazingly enough, I have a triangle. I do not have a right triangle. I have some sort of oblique triangle. So I'm going to have to use the law of cosines because I can't use trig ratios to solve this. We do have that this is 10 kilometers north. So what we need to know is how far is Deerfield or Middleton from Deerfield. So we want this distance here. The piece of information that this problem expects us to understand is when it says northwest, it's meaning perfectly northwest at an angle of 45 degrees. On a test, I would give you that information. But if we know that the angle shown is 45 degrees, we can find its supplement here to be 135 degrees. So now, when I need to find the side length, which let's just call it C, I have an angle C to work with. This becomes a very simple problem once we've got a sketch that makes sense, and we can use the law of cosines. C squared is equal to 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of 135. This becomes a very simple problem, and again, I can plug this entire right-hand side of the equation into my calculator. When I do that, I get that C squared is equal to 277.137. And when I take the square root of both sides, it gives me a value of C that is 16.647 kilometers. This is a word problem, which means that your answer has to be in words. What I'm telling you is you have to answer this question. So I could say Middleton is 16.647 kilometers from Deerfield. That is an appropriate answer.